From this problem, we are going to find out voltage of the battery. As per the loop law, the algebraic sum of increasing and decreasing voltages in a closed circuit must be equal to 0. Due to that reason, we can write VB is equal to 15 plus 10 plus 20. So VB is equal to 45 volts. From this electrical circuit, we are going to find out current in the circuit. So as per the junction law, sum of the current which are moving into the junction must be equal to sum of the current which are leaving the junction. So at this particular circuit, this point is acting as a junction. Now the current I is splitting into three groups: I1, I2, I3. I1 current is passing through R1. I2 current, that is 3 amperes of power, is passing through resistor R2, and I3 5 amperes of power is passing through resistor R3. So that current I is splitting into three groups at the junction. So sum of the current which are moving into the junction must be equal to leaving the junction, I1 plus I2 plus I3. So I is equal to, we can write 1 ampere plus 3 amperes plus 5 amperes. So equal to 9 amperes. Here is an electrical circuit and we should find out I2, current I2, V2, V4 and I4 also. To find out these all things, just you can analyze the electrical circuit properly here. I current, that is I is equal to 5 amperes of power, is passing through the resistor R1, and that I current is splitting into two groups. I1 is passing through the resistor R2, I2 current is passing through the resistor R3. That 5 amperes of power is splitting into two groups, so that I2 must be equal to 2 amperes. And these two resistors are connected in parallel. In the case of parallel connection, there is equal potential drop at the two ends of the resistor which are connected in parallel connection. Due to that reason, the voltage across the second resistor must be 2 volts. And these two currents, I1 current, I2 current, these two are joining at this particular point and passing through the resistor R4, so that current at this particular current which is passing through this resistor is 5 amperes. And V4 is equal to 14 minus 7 minus 2, that is equal to 5 volts. This is an electrical circuit, and now we should find out I1, I5, V3, V4 and V5 values in the particular circuit. To find out all these things, just you can analyze the circuit properly here. I1 current is passing through the resistor R1 and that is splitting at this particular junction, and I3 current is passing through the resistor R3, I2 current is passing through the resistor R2. I2 current is nothing but 2 amperes of power is passing through R2 resistor. I3 current is nothing but 3 amperes of current is passing through the resistor R3. So sum of these two things must be equal to I1. So I1 is equal to 5 amperes. And these two currents are joining at this particular junction, and these resistor R3 and R2 are in parallel. Due to that reason, potential drop across the two ends of the resistor must be similar. Potential drop across R2 is 2 volts, so that V3 must be equal to 2 volts. And these two currents are joining at this junction, so 3 plus 2, 5 amperes of current is passing towards this point. And now at this particular junction, again current I is splitting into two groups. I4 current is passing through the resistor R4, I5 current is passing through the resistor R5. Now current I4 is equal to 1 ampere of current is passing through the resistor R4, and 5 amperes of power is splitting into these two groups, so that I5 must be 4 amperes, and these two are in parallel connection, so that voltage across the two ends of the resistor must be similar to with each other. Due to that reason, what we can write, 76 minus 25, 51, and 51 minus 2 volts of potential difference across the two ends of the resistor. So what we can write, 51 minus 2, 49 volts. V4 is equal to 49 volts.